This video will show you how to use a motion diagram and what you can get from it. What you'll see here always when you draw a motion diagram, make sure you label which side is positive and which side is negative. Make sure that you have some type of scaling on here so you can see 5, 5, 5, 5. This one doesn't have any scaling, you wouldn't know what these are worth. So you need to make sure there's a number on there. If you want to label every number, you can. If you just want to label every other, every fifth, that's fine, as long as you can tell from the number what the scale is. And then when you put the dots on, you need to have your initial displacement labeled with X sub 0 or D sub 0, which is X naught or D naught for your initial displacement. From there, once you have these, what you'll do is you'll draw an arrow from your starting dot to the next dot, and you'll just continue down that line. And what those actually tell you, the length of the arrow is going to be your velocity, because each of these dots are 1 second apart. So you traveled 2 meters in 1 second, so that means your velocity is 2 meters per second for this part. And again, you traveled 2 meters, so it's 2 meters per second, 2 meters per second, 2 meters per second. You can also use this to find the acceleration. If I redraw these, 2 meters per second, 2 meters per second, 2 meters per second, and there's one more, but I'm not going to draw it. You can see all these arrows are the same length, and they're the same value. That's why they're the same length. And what that shows is that the velocity does not change as you progress down the line. And if there's no change in velocity, that means your acceleration is 0 meters per second squared. So from the dots, I can figure out what the velocity is between each of the dots, and I can also find the acceleration of the system. So these bottom two, which look very similar, it's just I started here on this one and I started here on the other one. These ones have acceleration, and we'll see that because the dots are not uniformly spaced. And if we look here, I've traveled 1 in the negative direction. So my velocity of that first one is -1 meters per second. Here I traveled -2 meters per second, -3 meters per second, -4 meters per second. Okay, so if I draw these again as arrows, I can figure out what the acceleration is. So my first one is my shortest arrow, 1 meter per second. Then I'm at -1 and -2 meters per second. -3 meters per second, -4 meters per second. So this is speeding up in the negative direction. And what you can see, look at the distance between here and where it needs to go to. Okay, see all these little arrows? They all have to be -1 long. So that means my velocity changed by -1 every time. So my acceleration is -1 meters per second squared. Okay, down here, we're just doing the opposite direction because I started on the other side where my X naught was. So my velocities now are 4 meters per second, 3 meters per second, 2 meters per second, and 1 meter per second. So these ones are positive because they're going towards the positive side. And then again, if I redraw the arrows, I'm gonna have 4 meters per second, 3 meters per second, 2 meters per second, 1 meter per second. Okay, so when I do that, you can see that in order to make this change happen, I need to go back this way, I need to go back this way, I need to go back this way. And each time I had to go from 4 to 3, which is a change of -1, 3 to 2, which is a change of -1, and 2 to 1, which is a change of -1. So since all my changes are -1, my acceleration again is -1 meters per second squared. So you can see in these last two questions, both of my accelerations were -1 meters per second squared. In this question, it sped up. In this question, it slowed down. But in both cases, my velocity changed by -1 each time. And that's what acceleration is. Negative acceleration doesn't mean you're slowing down. Negative acceleration just means that your velocity is becoming more negative each time by whatever value. So it became -1 more each time.